Section 11.7 is going to discuss exponential and logarithmic equations. Now, there's technically two different ways you can solve an exponential equation. I'm going to kind of wrap it into one. There's also two different ways you can solve a logarithmic equation. But we're going to start with exponential equations. So, exponential equations. These are equations where the variable is in the exponent. For instance, problem number 30. 5 to the x equals 12. Okay, well, you can't take the square root on both sides. That's not going to do anything. You can't raise things to the 1 over x power. There's not much you can do other than this one basic idea. This basic idea is this idea. If you have two things that are equal, say for instance a equals b, that's an equation. We want to treat both sides of an equation the same. I can take the log on both sides. So the log of a equals the log of b. Now you might ask, well, what good does that do? Well, the good that it does is it allows you to start using the properties of logs. And there's one property of log in particular that's going to be very, very useful in working with exponential equations. So let's try that on both sides here. We've got 5 to the x equals 12. What if I was to take the log on both sides? So the log here and the log here. Okay. Does that do any good for me? Well, start thinking about your properties of logs. Is there anything useful that your properties of logs allow you to do here now? Yeah, let's bring that x out in front of the log here. So I get x times the log of 5 equals the log of 12. And now I want to get x all by itself. So let's take a look at this. You've got x times something. The opposite of multiplication is division. So I can divide both sides by the log of 5. And get the log of 12 divided by the log of 5. And basically that's your answer. X is the log of 12 divided by the log of 5. Yay. Let's get a numerical value for that. So take out your calculators. So I want the log of 12 divided by the log of 5. You should get about 1.5493, etc. The one place it's easy to make a mistake is that you need a parenthesis around that 12. Your calculator automatically puts in a left parenthesis. You have to put in the right parenthesis to say, all right, stop taking the log here. Now let's check that. There's a nice easy way that you can check this. So let's see if we can't do that. And that is, let's take 5 and raise it to that power and see if we get 12. Now the nice thing is you don't have to type in that awful number in your calculator. Let's hit the 5, and then the raised to the power key is over here. 5 raised to the power of my previous answer. So there's a couple ways you can get that, but let me just show you this way. Hit the second key right here, and then the enter key down here. So second and then enter. Oops, crap. I'm sorry, I was thinking the wrong thing. So let's try that again. 5 raised to the power of answer. Sorry. So again, hit the second key. This time, right above the opposite key is a key that says answer. And it'll type in your previous answer. So 5 raised to the previous answer should give me 12. Yay, it does. So you can check these things. And quite often I will ask you to check your problems in various ways. So approximately, what, 1.5 for, oh wow, this is kind of a good one. Suppose I round to the nearest 10,000th place, right here. 1.54395. If I round to the nearest 10,000th place, what happens here? Yeah, it becomes a 40. You get a 1 here added to the 9, gives you a carry. So 1.5440 would be the answer on that one, to the nearest 10,000th place. Looking okay for the first one there? Certainly we've got a lot more that we can practice. What you're going to see as I go through these exponential equations is they're going to become increasingly hard. There's going to be more and more tricks. So try and pick up on the tricks as we kind of work our way up the ladder from the easiest problem to the more challenging ones. Okay, so let's try problem number 32 then. Five to the power of x plus 1 equals 3. Suggestions. Where do I start off on this one? With the logs. Thank you. Yep. So we'll take the log on both sides. Log of 5 to the x plus 1 equals a log of 3. Now here we got to be a little bit careful. This x plus 1, even though it's not written that way in the book, it's kind of in parentheses, and that whole exponent comes out in front. So I get x plus 1 times a log of 5 equals a log of 3. Now I haven't really stated it, but what base logarithm do I have here? 10. There's a couple ways that you could solve. You could distribute log of 5 to both terms in here and then work it that way. Let me suggest a different way. Let's divide both sides by log of 5 right here. The advantage of that is that it moves that log of 5 to the right-hand side, and I'm done with it on the left-hand side. In fact, I'm almost done solving, except for one thing. I've got x plus 1 equals the log of 3 divided by the log of 5. Yeah, let's move the 1 to the right-hand side. When I move the 1 to the right-hand side, what happens to it? Yeah, it changes signs. So log of 3 over log of 5 minus 1. Again, let's check ourselves here. Let's check our answers. Let's get a numerical answer and see if it works in the original problem. Before I play around with the calculator, how about some questions about the algebra? Are you okay there? All right. Again, you need to be careful by putting in right parentheses to close off your logs. So let's do it this way. Log of 3, right parenthesis divided by log of 5 minus 1. So there's my answer. Now you can check it in a couple different ways. You can check it just by doing 5 to the x plus 1 equals 3. So I should be able to do 5 to the answer plus 1, press the enter key and get 3. So let's see if I can't do that. 5 raised to the power of answer. Remind me, how do I get the answer? Second, and then the opposite key, good. Plus 1. So you need that plus 1 in the exponent. When I press enter, I should get exactly 3. Yay. Now, I'm not making this class and this course about doing things on the calculator, but you know, you might find it a little bit easier let me go back to this number here, and if I hit the store key, store in X. X is right here. If I store in X, then it might make it easier to type in some of these previous problems or check your solutions. I can do 5 raised to the power of X plus 1. And again, that should give me 3. So I'm just giving you different options so that you can check your work on these types of problems. Overall, our answer, quite often I'll ask for just this type of answer. On a few problems, I'll ask for a decimal answer. But more often than not, I'll probably want to see this as opposed to a numerical answer. Okay, how are we looking on 32? Thumbs up? Yes? All right, cool. Thank you. Let's try problem number 34. And like I said, what you're going to see is a progression in terms of the level of difficulty. So that's true with this next one as well. Problem 34 gives us 6 to the x equals 7 to the x minus 4. I got to confess, I have no idea what the solution to something like this was going to be like. So we'll see. It's going to be an adventure for both of us. How can I tell that this is an exponential equation? Yeah, variables in the exponent. Good. And right now, we've got one tool that we can use to solve exponential equations. So that is to take the log on both sides. When you've only got a hammer, everything looks like a nail, right? So let's take the log on both sides. What's going to happen? What am I going to do to rewrite this first? Taylor? Sure. The x is going to come out in front. What else? Good. And the x minus 4. So I have two terms that are coming out in front here. Thank you. We're using the power rule. So x log of 6 equals x minus 4 log of 7. And let's distribute this. So the reason I want to distribute this is because I need to get the x's kind of by themselves. If I divide log 7 on both sides or log 6 on both sides, I'm not really getting the x's by themselves. So I'm going to distribute here. I'm going to get x log of 6 equals x log of 7 minus 4 times a log of 7. I want to try and keep things on this one page, so I'm going to pull a little bit of a sleight of hand here. I want to get the x's together on one side of this equation. Now you could do that quite easily by moving this to the left-hand side and keeping this here. That'd be fine. I guess I want to move this to the right-hand side, which means I'll have to move this term to the left-hand side to get the x's on one side together. My reason for that is because if I move this to the left-hand side, what's going to happen to the sign of this term? It becomes positive, right? So I'm getting rid of that negative, which I kind of like. We'll see a reason for that later. So kind of a switcheroo here. Moving this to the left-hand side, and I'm moving this to the right-hand side. When something changes signs, it changes signs. So see if you can't write down the next line in this problem. So we get something that looks like this. The 4 log of 7 term on the left-hand side became positive. This term, when I moved to the right-hand side, became negative. You can't do any fancy quotient rule or anything like that here because you have something in front of the logs. In fact, my goal here is to get the x's by themselves. So maybe put a little star here in your notes because this is the tricky step or the key step. I'm not sure how tricky you regard it or not. But it's going to be 4 log of 7. I need to get that x by itself. So what I can do is factor it out. It's a greatest common factor. Like that. Almost done. There's one step left to get x by itself. What would that be? Oh, very good. I thought I was going to have to prompt you a little bit on that. Yeah, you've got this term, but it's just a number. It might not be a very pretty number. It's not as cool as, say, pi, but it's just a number. Some number times x equals some other number. Divide both sides by that number. So to finish that up, let me come over here. I'll get 4 log of 7 divided by log of 7 minus the log of 6 equals x. Now the real joy is trying to calculate that thing on your calculator. So why don't I give you a second and see what you can do. See what you can come up with numerically for this number. And then I'll give you some hints or tricks as to how we can do this in other ways that might make it easier for you to calculate that. And of course, it might be nice to check it as well. Okay, so I'm kind of curious here. Let's keep track of a few answers. What kind of answers are you getting? 50 point what? 4937. Okay. What else? I know there's some other answers out there. Don't be shy. 3.2218. Okay, good. Some people in support of that one. 3. What'd you get? So you get the first one, okay. Anything else? Got to be at least one more. Really? 3.1126. Appreciate that. Thank you. Anything else? All right. So the challenge about this one is that there's a lot going on there. So there's a few ways that you can do this. If you're going to do it just kind of as it stands, then you would type in 4 log of 7 divided by, and here's where you need parentheses because you'd have to divide by the whole denominator. So parentheses, log of 7, another right parenthesis because it's log of 7 minus log of 6, right parenthesis, boom. So 50.4937 is our answer, approximately. But tell you what, we can make our life calculating this even easier. We can use some properties of logs. Let's just do the one in the bottom. So I'll write this as 4 log of 7. What do my properties of logs say about a quotient? Log of 7 over 6. Now be careful. Log of 7 over 6 is not equal to the log of 7 divided by the log of 6. That's something much different. So when you're using the quotient rule, it's the log of the numerator divided by the denominator. Or excuse me, log of the first divided by the second, log of 7 over 6. So let's try it this way. Does that make it easier to calculate for you? 4 log of 7 divided by log of 7 over 6. Should get the same thing. We can get fancy here and store that in X. So hit the store key. It'll take your previous answer and store it in X. If I wanted to check this one, then I could put the type in both sides of the equations kind of alternately. 6 raised to the X gives me that. 7 raised to the X minus 4. And I got the same thing. Wow. Does anyone notice anything about these numbers? It's a real whopper. These are really, really huge. It's this E39. What's that mean there? It means times 10 to the 39th power. So it's huge, huge number. It's about the number of times that Donald Trump has said that he's going to make America great again. So, all right. Are we okay with problem 34 here? All right. Somehow I expect a phone call from his campaign telling me to cease and desist. Okay, let's keep going. Problem 66. Eight to the x squared equals 11. 8 to the x squared equals 11. Dakota, how should we start? Yeah. All right, good. So we'll take the log on both sides. Good. And what happens when I take that log? All right, cool. That comes out front. So I get x squared times log of 8 equals log of 11. Thank you, sir. Norman. Now what can I do? I want to solve for x here. What can I do? Divide by what? Perfect. Let's divide both sides by the log of 8. So x squared equals the log of 11 divided by the log of 8. Am I done? What else do I have to do? I have to take the square root of each side. So square root of x squared equals the square root of log of 11 divided by log of 8. There's actually something missing here, though. What is it that's missing? Ah, well done. There's a plus or minus root here. You need that plus or minus. Is it helpful to learn some calculator tricks? Yeah? Okay. Stuff like this becomes kind of a pain to type in, especially if you're trying to do it with square roots and stuff like that. So let me show you a different way, a different approach to typing that in. So what I'm going to do is first of all just calculate log of 11 divided by log of 8. Log of 11, need the right parenthesis there, divided by log of 8. What additional step do I need, though? I need the square root of that. There's a couple ways you can get that. You can just brute force, and don't do it this way yet. You can just brute force do the square root. You can do off your previous answer. But what I find the easiest is this. The square root was like what power? What exponent? Remember when we did roots and rational exponents? It's to the 1/2, right? So if I want the square root of that, the easy way to get that is to raise that to the 0.5 power. And dig this. When you press the raise key, look what it does. It takes your previous answer, puts it down there for you. So raise that to the 0.5 power, and we're done. It's a very painless way to get the square root of that answer. It's a lot more efficient. I mean, look, this is what you could do kind of in a brute force approach. You could do the square root of the log, you do all this stuff. But, a lot of people aren't really comfortable with that. So just trying to give you a different way to do this. Okay. Whatever way works for you. Let's actually see that this works. So we're going to I'll store that in X. And let's type in 8 raised to the power of X and then hit the square key. Let's see that I get 11. Yay! All right. Oops. Any further comments on 66? Let's take a look back at problem 22. And what I think I might do is I might try this one 2 different ways. In fact, are you ready to try this one? Are you ready to try one on your own? Yeah, this is probably a good one to try. 3dx plus 1 equals 27. And get a decimal value for this one, because it should work out nice and even. So try and get yourself a decimal value. Should I tell jokes to the video while you're solving this one? Yes. You weren't supposed to say yes because I don't got anything ready right now. The teacher gets mad at her student for text messaging and says, "Give me 2 pronouns." And the student says, "Who? Me?" Yeah. Hey, don't forget to tip your server, okay? Are you able to get a nice round numerical number? Maybe an integer value between 1 and 3? All right. So let's take a look at this one, maybe a couple ways. The first thing you should be doing is taking logs on both sides. Then the exponent comes out in front. Nothing dramatic is going to happen with the log of 27. That's okay. What else? Divide both sides by log of 3. You get x plus 1 equals this. I'll move the 1 to the right-hand side. And then when you punch it into your calculator, you should get 2. Yay. Now, the fact that we got such a nice, even answer suggests that maybe we could have done this a little bit differently. And in fact, there's at least a couple different ways that we could have done this. So, first things first, are you okay with problem number 22? Now, I guess the one thing that catches my eye, and I'm not sure it's going to catch a lot of people's eye, is that 27 is 3 to a power. So, if you had noticed that, you could say, oh, well, that's really 3 to the third power on the right-hand side. And then, because the bases are equal, the exponents have to be equal. So in other words, x plus 1 equals 3. So x equals 2. Now there's a couple problems in the book that are like that, but you don't need to solve it this way in order to get the answers. In fact, the frequency of these problems like this is rare. And the method we use is going to solve all your exponential equations, not just the ones that are set up really, really nice. So I'll mention it. I'll throw that out there. There is another one like this, but, you know, like I say, I'm not going to emphasize that approach. Are you okay with exponential equations? So I think they've gotten about as hard as they're going to get. You know, let's do one last one. Problem 38. I want to think if I want to mention anything more about this. Yeah, let's take one last look at problem number 22 before we do problem 38. The alternative approach on this one is this. We've been dealing with log base 10 on both sides, but sometimes it's easier to take log of a different base. So coming back here, what if I took log base 3 on both sides? How would that change things? Well, it actually would be a nice difference for us. And let's see what would happen. First of all, on the right-hand side, what power of 3 gives me 27? Third. And on the left-hand side, I'll do this in 2 steps, but you're going to see where we're going to get pretty quickly. I'll take out the x plus 1, and I have the log base 3 of 3. What power of 3 gives me 3? First power. So this is really a 1. And it shows you where we got over here, kind of by thinking about this in terms of exponents. So it's x plus 1 equals 3, x equals 2. It's a different way to do that one. But it's nice if you can work with a logarithm that matches the base. You get some really, really nice cancellation here. So the reason I mention that is because I have an eye on problem number 38. And we'll look at 38. In fact, the one thing that I want you to take away from this approach is this right here. These two operations, when you do the log base 3 of 3 to some power, simplify down to the exponent. Those two cancel. All you're left with is the exponent. So that's kind of nice. Let's apply that. Problem number 38. And that'll be it for exponential equations, at least for a little bit. We'll start working with logs. E to the 3.3 t equals 9.1. Before we start charging ahead and taking logs on both sides of this, let me ask you a question. What bases of logs can you directly calculate from the face of your calculator? If I want to take the log of something, what base can I use that's programmed into your calculator? 10 and E. 10 and E. If you ever lose track of that, take a look at your calculator. You kind of got a built-in cheat sheet right here. Log goes with base 10. You see that 10 to the x right above it. ln goes with base e. You see that e to the x right above it. So because e is one of the bases that's programmed into your calculator, let's take the log base e on both sides. Log base e of e to the 3.3t. Log base e of 9.1. Now what else could I have written other than log base e? What other notation do we have for that? ln. Alright, so ln. So this is really ln of 9.1. That's what you're going to type in on your calculator. But on the left-hand side, I'm kind of happy I wrote log base e of e to this power. I'm hoping that it suggests some simplification on the left-hand side. Who haven't I heard from yet this morning that can help me simplify the left-hand side? Sam? All right, log base e of e becomes 1. What's going to happen with the exponent? All right, so we'll do this in 2 parts then. You're exactly right. Log base e of e becomes 1. So what we're left with is 3.3 times t. Now, if you're comfortable and confident, you can kind of skip this step. You can go from right here down to here. There's nothing wrong with that. In fact, I'd be happy to see that. I'd be impressed to see that on an exam. So ln of 9.1 divided by 3.3, that's t. Yay. And you can get numerical values. You can take your numerical value and test it back there in the original equation. But that's our solution. Are you okay with logarithmic equations? Tell you what, I'm going to cut the video here. That way it'll be just exponential equations, and I'll have another one, so it won't be so long. So I'm going to pause it here, or cut it here. And then we'll assign homework when we get to the end of section, at the end of logarithmic equations.